Good morning, ladies and gentlemen. I'm Seongick Cho, the director of the Korea Ocean Satellite Center, the one and only the satellite operation agency, assigned by the Korean government, the Ministry of the Oceans and Fisheries. So, first of all, I'd like to. It's my privilege to have a chance to introduce the GOCI and KIOST, one of the tactical research assets in KIOST at the KIOST Tropical Ocean Workshop. So KIOST, the GOCI, the Geostationary Ocean Color Imager, is the ocean observation, the satellite located in geostationary orbit. It was already launched in 2010, and the expected lifetime is about 7 years. So it means that we have only 1 year to the expected lifetime. But after the dedicated analysis of the fuel implemented into the satellite platform, we expect that we can assess the 2 or 3 more operation years for GOCI and KIOST. So it means that we can acquire the GOCI images until the 2020 or something like that. So the orbital location of the GOCI and KIOST is in geostationary orbit. The geostationary orbit means that the revolution, the angular speed of this orbit is identical to the rotation speed of the Earth. So it means that the GOCI can observe the specific area in the Earth's surface in 24 hours per day and 365 days per year. So it enables the hourly observation of the Korean Peninsula and the near oceans and 8 times per day. So comparing with the human eye consists of 3 cone cells. In terms of the sensitive wavelengths, so it represents the red, green, and blue. So it means that human eyes consist of the 3 different spectral bands in the visible light. And in case of GOCI, we have the 6 spectral band. So it means that 2 times more spectral band compared with the human eye in the GOCI. And we implement 2 more the near spectral band dedicated for the atmospheric corrections. So some people might have some question why we need the satellite for the ocean observations. So before answering that questions, I'd like to show the application results of the GOCI. So this image shows the huge bloom which was occurred in 2015 in Jeju Island, the largest island in Korea in south. And the total amount of the bloom of the Sargassum brown algae is about more than 121,000 tons, and it costed more than $1 million just for clearing these Sargassum algae. So if assumed that the human look the oceans from the space, this is the image from the observation of the ocean by the human eye. We cannot find any evidence of the Sargassum, but after the dedicated data processing of the GOCI, the additional spectral band, we can find the picture of the Sargassum blooms around the Jeju Island, and this is the final result. And this kind of the dedicated, the state-of-the-art processing algorithm was solely developed by the Dr. Youngjae Park, the vice president of KIOST and the chairman of this session. Okay, so this page may be it gives you the brief answer for that question, why we need the satellite for the ocean observation. The figure left side represents the observation result of the sargassums in 2017 by the observation of the in situ measurement using the research vessels. It shows that there are some kind of the sargassum blooms in the southern part of the Jeju Island, but right side you can find the rest and the most part of the sargassum blooms observed by the GOCI, the satellite. So in the case of the in situ measurement, can reveal the sargassum only the small part of the region, but satellite itself can observe the whole part of the sargassum blooms around the Korean Peninsula simultaneously and 8 times per day in every hour. Besides the sargassum, the GOCI can observe the red tide, the hamperage blooms, and the green tide, which was quite the huge blooms in the 2008 in the Beijing Olympics. So this is a sample. So please understand that I have assigned only 5 minutes for the presentation. So it spent only the 5 minutes. I have to hurry up to fulfill the allocated time. So this is the moving picture of the tidal flats. This kind of the observation can only be achievable by the GOCI, which enables the hourly observation of the oceans. Okay, so this is a sample result of the yellow dust in the spring season in Korea. So the one of the issue was GOCI is the observation area was GOCI is limited in the red boxes. So we have decided to develop the GOCI-II, the successor of the GOCI, and we expanded the observation area in this full Earth disk over the geostationary orbit. So it means that in the case of GOCI cannot observe the Philippines and other tropical ocean area, but GOCI-II can observe the Philippines and other tropical ocean areas around the regions. So for the moment, we have a plan to operate the full disk observation 1 time per day, but we can implement this kind of the extended area concept because the extended area can observe this area 2 times per day, before noon and afternoon. So in the case of Philippines, only the 4 slots of the GOCI can cover the whole around the land side of the Philippines, and the 8 slot images can cover the whole region of the Philippines. So it means that it takes only 4 minutes to observe the whole Philippines area, or 8 minutes. It takes 1 minute to observe the 1 slot image area. And one of the key issue of the satellite-based ocean observation is the uncertainty. Normally, the expected uncertainty, measurement uncertainty is about 30% after the atmospheric correction and other dedicated processing. So the increased the data quality of the satellite-derived the observation result, we need to organize the international ground-based ocean observation network. So this is some kind of the suggestion from KIOST to implement a dedicated solar irradiation spectrum measurement facility for the GOCI-II calibration and validation activities. So this is the current development state of GOCI-II. So the integration phase of GOCI-II is successfully accomplished in last week. So we are in the the ground test campaign process. So expected launch date of GOCI-II is 2019. It means that we can provide the GOCI-II observation-based data, especially for the Philippine area, before the end of 2019. Thank you for listening.